Lesson 7, Rationals, Functions, and Variation. Alright, so what we're going to do is we're going to look at rational expressions and we're going to simplify them. We're going to remember the rules that we talked about this week. Some of this stuff will overlap with things that we've mentioned before. Please try to eliminate simple errors, okay? First and foremost, a mistake most people would probably make on this one is that they would cancel the 2x cubes altogether and possibly just say 1, okay? Another thing that they might look at is just canceling the 2x's and thinking that's 1 cubed over 1 cubed. Just trying to help you out as far as most common mistakes. My suggestion to you is for you to actually distribute the bottom piece and then cancel thereafter so you don't have any more parentheses. So the bottom is 8x cubed. The top is 2x cubed. Do you agree? Yes. And then it would all reduce to what? 1/4. Nice. Because the x to the power of 3, x to the power of 3 cancel to a form of 1. Now, this are they the same or are they different? They're different. Can you tell me what concepts revolve around them and what should I be thinking about so that I don't confuse the two?
I don't think you can cancel 6 and 6 because that would be...
So you cannot cancel these. He's correct on that. Can someone tell me why? Because the addition. You can only cancel between multiplication. You can't cancel between addition like this. Forms of 1. Okay? What else can you tell me about this? How many terms should the denominator be when you are adding fractions? Listen to that question. Of any fractions, how many terms should the denominator be in order for you to be able to add fractions? 1. Nice. So can you look at this, and the most common mistake people do is that they will break this up like this because they're not realizing to add fractions, the denominator is 1 term. Okay? How many terms do we have in our problem? 2. So we can't break it up like this, okay? If it was this one over here up top that I wrote over here, this you could break up for sure into 2 because of the fact that you recognize and understand that there's only 1 term in the denominator. Okay? And guys, when I say 1 term, what if it had this in the denominator? Now how many terms is this? It's still 1. Good. Because it's fused together, combined together through multiplication. Okay? Alright, so with that being said, we have to look at it a different way to simplify. What would we do?
Pull up 3n.
Yep. We have to GCF the denominator with 3n. And we would have 2n plus 5 left over. Okay? Can we now cancel this 6 and 3? Yes or no? Yes. And the reason why is because between this now 1 term. Look, you just changed that. Like, I understand this is 2 terms in this binomial. God bless you. So, but if I asked you, how many terms are in the denominator? Here, it's 1. Here, it's 2. Do you understand? Just the way it looks and that multiplication that is sitting there ready to be canceled with. So 6, 3 cancels 2, 2 over 1. N cubed and n would cancel to n squared. So anybody, what would be my final reduced answer?
2n squared over 2n plus 5.
2n squared over 2n plus 5. Okay? Again, do not try to do this stuff with something that has more than 1 term in the denominator. Use the GCF and then cancel, reduce. Okay? Looking at this, My hopes are that you don't try to cancel this 3 and 6, and you don't try to cancel the x and x squareds, because you cannot cancel between subtraction and addition. So let's factor the bottom. We need to create the bottom, which currently has how many terms? 3, and we wanted to make it have one term by factoring. What are the factors, guys? Yep. Okay. And now you see the entire binomial will cancel with this binomial piece, right? To a form of 1, to where my full answer reduced would equal this. Okay? Let's look at this one over here. Guys, 9 out of 10 times, when you see something that needs to be factored, 9 out of 10 times, it will cancel with that. That's how the tests are created. Okay? That removable discontinuity cancellation of 1. Okay? So, we could kind of guess and check this. Some people might try to factor by grouping, where you multiply -7 and 2, and so on and so forth. My hope is that you adopted the new way to do this. The fast way is looking at this first number would be 2x, and x would give us that if we multiplied. The last term is 7, so I'm thinking factors of 7, which are just 1 and 7. And I have a choice. I can put 1 here and 7 here, or I can put 7 here and 1 here. So what I want to do is I want to see what are these multiplicative numbers going to create. I see a 7 and a 2 right now. So that 7 and a 2 can create a 9 or a 5 if I add or subtract. And that's perfect because I see a 5 right there. We'll take care of the negatives in a minute, but I see the 5 is there. So now I just have to figure out, I want these to multiply to get a -7. So that means this is going to be a positive, this is going to be a negative, or the other way around. And again, I'm glancing at this bottom piece and saying, that might cancel. So if I looked at this, I see now a -7 and a +2, which of course gives me that -5. These cancel, and the final reduced form is 2x minus 7. When you take tests, don't just try to look at it from a student's perspective. I mean, you guys are the elite. With all this practice that we've been doing, try to look at it as if you were creating that question. Find those commonalities and those subtle things that they're trying to see as far as steps and processes. All right. So, I might have gone a little bit too fast. Let's mention what n cannot be. So this is my original given expression. This is my simplified form. And if I asked you, what are the n values of which this would error out? -5/2 is one of them. And then what? 0. So these two n cannot equal. And the reason of that is that when we factor these forms, if I put a -5/2 there, what would it make the denominator? 0. Can you divide by 0? No, because the answer of divided by 0 is what? Undefined. Undefined. Okay? The other piece is 0 right here. Okay? So this is the reduced form, but with this little caveat. You cannot have n is equal to -5/2 or 0. Is there a caveat here? X cannot equal -2, and don't just look at the answer, look at and 3. So x cannot be -2 or 3. And the last one, what would the last one be? -1, yeah. From the original, x cannot equal -1. This is almost like, treat it like extraneous solutions. You got to check and you got to figure out which ones it wouldn't work on. Now, we've seen functions given to us that look like this, which the parent function is a quadratic.
Mr. Gomez,
Oh, sorry. Go ahead.
going back to the simplifying radicals, on the first one, shouldn't x not be able to equal 0?
Oh, what is it?
Oh wait, no, because it was
You didn't really cancel anything, you just simplified it. I mean,
No, that's a good question, though. Trying to figure out how to answer it without confusing you.
because it doesn't have a variable in the final answer, it's a constant, so it doesn't matter.
0 rows.
So let me ask you this. This right here supported the fact that it can't be negative 5/2. And in the factored form, even though it was still cancelable, able to be canceled and reducible, we included 0. So you're exactly right. We should include 0 here from the original piece. But I think someone said it. The original piece, isn't this a form of 1? So you could say, let's say the answer was 1/2. Well, we don't know if this came from 1x to the power of 10 over 2x to the power of 10, because then we could create anything to say x cannot equal 0. Does that make sense? Because it was fully cancelable to a form of 1, and these necessarily weren't, we account for these, but we don't have to account for those. That was a really good question. Okay? I hope that answer was sufficient. Alright. Alright. The parent function was x squared. In PEMDAS order, the first transformation was 3 to the what? A shift 3 to the right. What's the next transformation that you see up here? In PEMDAS order. A reflection across. So let me ask you this. Should I say horizontal or vertical reflection?
No.
I don't have to, but if I do, it helps me know which axis it's reflecting across. So the negative, is it inside with the x?
No.
No. So it will be a vertical, this is a vertical reflection, so let's say that you have this x-axis. It's jumping up or jumping down, so it would be a reflection across the x-axis. Then it's a stretch by what?
2.
And then a shift
Right.
5 up, because it's a vertical one. Vertical is up or down. Alright, good. Now this, to me, is very easy. As far as for students to get it and they understand. But when we look at this, don't make it more difficult than what it is. Okay? Guys, all of these, what's the parent function? F of x. So if I'm looking at the parent function as it started here, and now that changed, let's be descriptive. What would we write?
Shift left.
A little bit more descriptive.
Shift right by k.
Horizontal, shift, k units, what? Right. Because it's with the x. Remember I was saying this week. If you're with the x, you're the opposite. If it's outside of the x, you follow the rule. Alright, so let's jump around. What would this one be?
Reflection of the y-axis.
A little bit more descriptive. I really want you to go for that first one, okay? Because the horizontal is with x, vertical is with y. Okay? And that means, guys, look, horizontal would be anything in these parentheses. Vertical would be anything outside of those parentheses. So say it one more time. Horizontal.
Reflection
Yep. Horizontal reflects or reflection
over the y-axis.
across y-axis. How about this one?
vertical shift,
Yep. Vertical shift
K with
k units up. This one?
That's a
Vertical, good, because you're outside, right? And you can already start picturing this. A vertical what?
reflection over the
Yes. Vertical reflection across the x-axis. Now this extra piece is just saying k is greater than or equal to 1.
Vertical stretch by K.
Okay. Is this right or wrong? It's wrong. This should be just strictly greater than 1. Because you can't be equal to 1, guys, because if, let's say your height is 6 feet, and you multiply your height by 1, nothing's stretched, nothing compressed, okay? So it has to be strictly greater than 1. So we're going to say vertical stretch by what?
Greater than 1.
By a factor of k. Well, this one. Remember that first word?
Compression.
Not vertical. Right here, right here, right here.
Oh, sorry. I was put out.
No worries. Horizontal.
Shift.
Yep, horizontal shift. K units left. What's another way of saying shift that you'll probably see on a test? Translation. Nice. Okay. And then this one. Perfect. Vertical shift. K units down. And this one says, so this one's also incorrect. This is probably the first mistake I've caught on this entire curriculum so far, this whole week, which is awesome. The accuracy on that, because I think I told you, even textbooks have mistakes. It should show that, right? Okay. And what would this be? Vertical compression. By a factor of k. Oops. Okay, there's one that you will possibly see that is not up here, and it's one that is commonly missed. Let me see if you,
Compression and stretch.
nice. So if we look at f of k of x, okay? And we say k is between, oops, 0 and 1.
Horizontal stretch.
Nice. It will be a horizontal stretch, don't get it wrong. Remember, you're with the x, by a factor of what?
KX.
1 over k. Remember how you have to take the reciprocal? Let me give you an example. Let's say that we have a square root function. So this is my default, and this is what I have. Guys, right now, it looks at first glance like a horizontal what? Stretch. It looks like a stretch because 2 is bigger than what? 1. But with the x, we always do the opposite. So it's not a horizontal stretch by 2, it's a horizontal compression by 1/2. Remember, you have to take that reciprocal there at the end. You with me? And let's say that it said 2/3 x. That would be a horizontal what? Stretch. Because right now it looks like a compression at first glance because it's less than 1. But horizontal, you see what I'm saying? Is always opposite, so it would be a horizontal stretch by a factor of what? 3/2. Are we good to go on that? Okay. I was surprised they didn't have that. Okay. So, given f of x is equal to the following, find f of 0. Should we do synthetic substitution if it's f of 0? No, just plug in 0 and what do you get? -5, otherwise the y-intercept. Okay? F of -3. Some people will do this. And you are more than welcome to do this, as long as this happens. Guys, and I know you know the math, but I'm trying to help you become as perfect as you can in this time constraint. Please watch those parentheses. What would the answer be?
It's
4. And if we did synthetic substitution, which I would do that, 2, -6, -3, 9, 4. It's still the same thing. It works with small numbers the whole time, and you never really have to go big, even if it's cubed or to the 4th. Find all the values of x such that the answer right here is equal to 0. All this fancy word or words really just asking you to do what?
solve for minus
Set it equal to 0 and
solve for x.
solve for x. Factor, right? So if we factor this, my hopes again is that you look at this first term and you know that these two will multiply to get that 2x squared. Then you look at this last term and you know that these two will multiply to get 5. And it's either 1 and 5 or 5 and 1. It's a small number, so I'm going to put 5 here. Because if I put 5 way over here, I have a 10. Those are kind of extreme, okay? So number sense will help me show that 5, 1 goes there. And now I just have to make this, or check that it does happen. 5 and a 2, the 5 would be positive, and the 1 would be negative. Okay? So what is x? -5/2 and 1. Do we have to check these for extraneous solutions? No, because my original problem's domain was what? All real numbers. And that was from the video of lesson 6. Okay? Huge as far as when it comes to checking for extraneous solutions. Okay. So write a linear function in slope-intercept form. We have 2 whats are given to us? 2 points. Nice. These are points. We're not used to seeing them as points, but those are points. And if you need to write the x and the y as coordinate points so that you don't get confused, by all means do so. Okay? So rise over run. So y2 minus y1 over x2 minus x1. Let's say someone didn't do that. They did y1 minus x2, and they did it over x1 minus x2. Would we get the same answer? We would, as long as we don't confuse the order, right? We can't say 3 minus a -6 over -2 minus 1. We can't do that. If you grab from one point first, grab from that same point when you go to do the x's. Doesn't matter, they're interchangeable. So the top would give us -9 over -3, which is 3. Just like this would give us a +9 over a +3 is still 3. So the slope is 3. What's the fastest way to get to this if you have a slope? What would you suggest to do?
So
Check one of the points.
It's like an equal.
Check one of the points. Okay, plug in points.
See the difference.
Here we go. There's 2 ways to do this. You could see 1 and 3, and because it's not negatives, I'm going to go ahead and use this one because it's a little quote-unquote easier. And you could say 3 is y, 1 is x, my slope is 3, so now just solve for b. Do you agree? What's b? 0. So it'll be y is equal to the slope x. Done. Or, I don't think they're going to be that easy. I hope that you go for the point slope formula. Okay? Y minus y1, because you use this all year in calculus. Might as well get used to it now. And if we use the same point, it'd be y minus 3 is equal to this slope of 3, x minus that x value. You with me? And if I distribute this, I get 3x minus 3 on the right. And when I add that over, I still get 3x. The reason why I want to show you that is because I believe you'll have fractions or more difficult numbers. And to find that b would be a little bit more daunting doing it this way, and experience and watching students test throughout the years, than if you were to do it point slope formula. I'm huge on encouraging point slope. Okay? Alright. Given the function, what is the effect of the transformation on the y-intercept? What would you say? It just moves down 2. So it shifts down 2 units. Now visualize it. And if I asked you, is it a max or a min, what would you say? It's a min. And what does the min equal? Let me see if I can get you. Yeah. The min equals -2, or y is equal to -2. What's the other question? Where does the min occur? So min occurs at x is equal to 0. As we know, this graph is this. So 0, oops, 0, -2. And this is the what it is, and this is the where it's occurring. Okay?
Could you give a point for that? Where
So, can you give this? No, you would get it wrong. Like on a, let's say it was an AP calculus exam, you would get it wrong because they know you don't know what, where, and what it actually equals there. That the y and the x have different meanings. And if you just do it like this, that's showing that you just want to play it safe and get the point, that you don't know which one it is, you know what I'm saying? Or that you don't know it. Okay, so I'm trying to expose you to that. This is the what it is, or how much it equals, and this is the where it's located. Okay, and you start learning that when you get into physics. Like, what's the velocity at time t is 4 minutes. You know what I mean? So given f of x is the following, given g of x is this, find the composition that could also be written as f of g of x. So compositions, right? Which one goes first? The innermost one, or the one, quote unquote, closest to x. Okay? So g of x is all of this. And what we're going to do is we're going to plug this in, our input variable, in the new place. Okay, so think of, since f is the most outer shell, this is going to be your most outer function. Okay, and g of x, otherwise the answer to g of x is all of this, would be placed as the input of the other one. And it would simplify to this. So f of g of x is equal to this. Guys, if you had f of g of a number, would it always be a constant over here? If your only variable over here are x's, then yes. If you have different variables, then no. It could be in terms of other variables. Alright. This one says take f of x's quote unquote answer and plug it into, I might have a little bit too much highlight going on. Alright, so take the answer to f of x, which is this, and we're going to plug it into the input variables here for g. So you can build your shell for g, and that's right, g of f of x. You're basically going to put in where those variables lie, your entire answer because it's the input of this new function that you're building. Alright, so let's simplify this. We have to FOIL out or distribute this first piece, and without showing work, what's the final distribution of this? X squared plus 10x plus 25. And I was trying to see if I could get you guys, remember, when you have an addition sign here, you have to pay very close attention that it's not the same as x squared plus 25. That is a very, very common mistake. This shows a multiplicity of 2, so that when you FOIL, you get this. Okay, the outside is 5, the inside is 10, or sorry, 5, so that when you add it together, you get 10. Okay, and then this just distributes, and then let's simplify it. What is our final answer?
X squared plus 8x plus 36.
Plus 8x plus what? 16. 16? Okay. Yep. All right. So again?
We're not back checking, sorry.
Oh yeah, this is it. We're done. So now we finally have one to where it is going to have an actual numeric input, but we're going to still do it the same. Okay? We're going to put that -1 into G, see what we get, and then put that answer into F. Okay? So let's do this part. Oops. Let's do this part first. G of -1. Okay? That means I'm going to go to G, and I'm going to put a -1 everywhere where I see an X. So it'll be -1 squared minus 2 times -1 plus 1. What do you get? 4. So all of this came out to an answer of 4. So we're going to treat that output answer as our input variable now in F. So what's my final answer for this? 9. Good. Yes?
So I know it doesn't save a lot of time on this one, and I know that it's not likely to appear on the test, but if we've already had the simplified equation previously, could you just plug it into?
Yeah, you could do that too. Yep, for sure. So he's saying, let's say you had this and you got it simplified, and then the next question was something that looked like this. He's saying, could you just plug this 0 where this x is at to get your final answer? And the answer is yes.
Because we already have that.
Yeah. Okay? Which also, I'm glad that you asked me that question, because something that I haven't yet shown you guys that I definitely want to show you with the calculator deals with function compositions. Okay? So real quick, follow me. What I'm going to do is, let me sign in first. And then what we're going to do is we're going to actually show how you can make this much faster. Because guys, if this is a calculator question, you can fly, you can fly with it in the respect of storing your function. So some of you know this, some of you don't. Here we go. My two functions are x plus 5. And I'm going to show you two ways to do this. New document, calculator. Control, add a page, press 2 for a graphing calculator. And my first function is x plus 5. And I'll enter. My second function was x squared minus 2x plus 1. So here we go. Tab, x squared minus 2x plus 1. And what I want to do is I want to do a function composition. Let's do f of x of g of x. Like, let's see if we punch this into our calculator, would we in fact get the answer that we got before? Okay? So let's go to our calculator page. And it's cool because on our graphing calculator page, you saw that these were F1 and F2. Guys, these tabs, they talk to each other. So if I did f1, which is f of x, but I did f of g of x, which is f of 2, would I get the answer that we got? Yes. Do you see how I did that? Okay. Let's try b. Let's try g of x, which is stored on page 2. Let me go ahead and tab it and show you. G of x, which is f2, I'm going to do f of 2 of f of 1 of x. And we get what we got from here. And last but not least, I could do f of g of negative 1. And sure enough, I get 9. Now, me, I show you the graph because some people like the graph. I don't. I don't like the graph at all. I like to store it on this page immediately. So what I would have done, first of all, let's delete storage. Menu 1.4, okay. Menu 1.5. And what I would have done is said x plus 5 is f of x. And then I would have said x squared minus 2x plus 1 is stored. So control var, control store. Oh, I'm just realizing. So x squared minus 2x plus 1, control var will store it as g of x. And what's cool, because now I can do this, guys. F of g of x, just like my paper, and it simplifies it. G of f of x, and it simplifies it. I could also do f of g of negative 1, and it goes to 9. Cool stuff. Okay? And if you get some ridiculously hard question that's like f of x, well then, there you go. Yeah. You with me? Okay. Yes, the calculator, guys, if you have it, this is why I concentrate on the non-calculator portion so much more, because the calculator stuff that I show you, people are doing very well in those calculator portions of the PSAT and SAT. Alright, here we go. If you know how to use it, you still have to know the math to be able to use it. You know what I mean? So if you don't know the math, you won't do all the work per se. Alright, so let's move on. Use structures to isolate or identify quantity of interest. Okay, so using the area of a triangle formula, which is 1/2 times base times height, solve for the height in terms of the area and base. Guys, when you see these two words, my hope is that you treat this as an equal sign, and whatever is in front, that's the variable that you're trying to get by itself. So learn how to use the words in terms of. Learn how to speak this. I think I might have already asked you guys this. I don't know. I can't remember. Can someone use the words and the letters, but use in terms of in this variable to read this like a sentence to me? C in terms of what? R. C in terms of R. You can write that down if you need to. C in terms of R. How about this one? What's that? V in terms of R. So people would say V in terms of pi and R. Pi is not a variable, so that's not how you read it. Pi is a constant. You with me? So how about if I said how would you read that? P in terms of L and W. Okay? Alright. So it says, now that we know what in terms of, let's get the height all by itself of this equation that we were doing. To move this 1/2 over, you'll multiply by 2 over 1. To move this b over, you're going to divide. So 2a over b is equal to h. Otherwise, h is in terms of a and b. The in terms of will help you create the manipulations of equations that they're wanting you to solve for. So it says the equation of the surface area of a cone. Okay, so you have this is like the top of a cone. And then this right here is the lateral area. So basically the cone part all wrapped around. But not the volume inside, just the outside surface area. And what is the slant height L? And L, guys, is right here. In terms of the area and radius. Okay? So when it says this in terms of, I look in front and I'm basically asking myself, solve for L. Get L by itself. Okay? Some people would move this pi r squared minus or over, so it'd be subtracting this from a, and then they would divide by negative pi r, and this is the answer. L is written in terms of a and r. Or I'm a positive coefficient kind of person, so I would probably have moved this piece over and then subtracted the a and then gotten this. Mathematically, guys, we talked about this week. This is equivalent to this. Mathematically, why? You're just taking one and multiplying it by a form of 1 to get the other one. So if I wanted to multiply this by a form of 1 to get this, what would that form of 1 be? Negative 1 over negative 1. Perfect. Good. Alright, direct variation, and then we are done with this unit or lesson. Direct variation and inverse variation. This deals with division, this deals with multiplication. So, varies. Almost, I treat it like in terms of. Okay? If I see varies, I'm going to write equals k where the word varies is located, no matter what. Now it says x, so we're going to put x varies, it's already written, inversely, which I know is division, with y. I think it's so much easier. And I remember back when I did it too, I made these so much more difficult than what I needed to because I was using intuition. I needed to know the verbiage of math, and it easily organizes this in an equation for me. Because now, if x is 6 and y is 3, my goal is to find k. It's called a proportionality constant. And k is 18. Now, I've just created, I'm going to create this general, non-specific equation, and I'm going to make it into this equation because I have found, because I have found k. The work that I've done was to find my proportionality constant. Because now it says find x when y is 7. Anybody, what's the answer? 18/7. So much easier, right? Now, this work that I did, guys, to find k so that I could go from here to here, I want you to tie it with something you've done before. What does it feel like you've done before many times that kind of feels like this process to find k? And if I tie it to it, your memory will remember this, and it would be hard to forget. You've done this before.
Density, mass, and volume.
Ooh, you might be thinking a little bit too higher level. I was thinking of this. We find the slope first, right? and then we find the y-intercept. Let's say we found the slope, and we got a slope of 3. I want you to look at this arbitrary general equation like this. Because your goal here is to find k. What's your goal here to find? B. So let's say I had a point 1, 4. I could put that 1 in for x, that 4 in for y. So what's B? 1. That's like you finding k here. You see what I'm saying now? Is this starting to make sense? So if B is 1, then I can make this general solution into a more specific one that has a specific y-intercept of 1. Do you see what I just showed you there? Because otherwise, this general equation of 3x, guys, could basically look like this. You could have 3x, which is a rise of 3 over 1, could look something like, let's say this. But here's the thing. If you don't have a b term, whoops, this is not going to let me. If you don't have a b term, and it's not a specific b term, it could be here, it could be here, it could be here. You see what I'm doing right now? It could be anywhere. This is called a general solution. It's infinite fields of general solutions that could possibly exist. But when I give you a point, like we did back here, which was 1, 4, I'm giving you a specific point where it would lie. Ooh, this kind of worked out without planning it. That would be the specific answer. This right here would be the specific answer. You with me? That's what's going on there. Okay, so make those direct. Direct variation sometimes won't say direct. Okay? It will say varies as x and, you know what I mean, as x. So if it doesn't say direct or inverse, by default, I want you to look at it as direct, which is multiplication. Okay, so let's do this last one. So y varies. Please don't forget the equals k for varies. Directly means to multiply. And then it says the next letter is x. You with me, guys? And it could say the price of admission varies directly with the time or the hour that you bought something. So the price of admission varies directly with time. You see what I'm saying? T for time, A for admission. Just trying to get you of where and why you use these. So now it's just cake. X is 2, y is 5, so that we can find our proportionality constant of 5/2, so that we can use this like we used this y-intercept up here to make this general form more particular. Which now, you give me any x, I'll give you a y, because it lands on that solution equation. Do we get it? Okay. Okay, so I believe this is, yep, this is the last slide. Here's how you're most likely to see these problems on the test. Write the formula for the following. Z varies, so Z varies directly as the square of x and inversely as the square of y. What do I do? Put it over y squared. Let's say that your multiple choice answers look like this. Maybe not. Oh, let's say that it looks like this. is this equivalent to that? It is equivalent. Because exponent powers, you would apply it to the top and to the bottom. Remember, you'd multiply by those ones that are in there? Okay, real quick, that's the answer. They're both the answers, but I want to help you out a little bit. Let's say that you had this. It would go to this, because you multiply powers to powers, but it has to apply to everything. You see what I'm saying? And then you would finally simplify this to that. Okay? Even if there was a z here, let's say to 4, this would also go to this, to be z to the negative 4th, which would make this go down here as z to the positive 4th. Do you understand, guys? If and only if the inside is all one term.
Wait, so on that first example,
This one over here?
yeah. So first, to find the x over the y, would you have to separate it? Or
So the only manipulation that I did between here to there is that I saw that they have a common power of 2. That's it. If it was with the k, it would be different, but
shouldn't the k still end up being divided by the y? Or the y being divided by the k, or whatever?
that's a really good question. A lot of people have this misconception. Look, can someone tell me, the way I'm looking at this right now, what is the full denominator? Like,
So like 1y.
it would be this, right? The full denominator of k would be 1. And isn't this the same as that ultimately? Yes. That's what I'm saying. So with fractions especially, guys, help each other out, or help yourself out with those over 1 bits, because a lot of people don't understand the difference. Let me show you this. Is this the same as this? No. Because order of operation says multiplication would happen first in division and then subtraction. So in our calculators, or the 84s, the old calculators that I used to use, when I wanted to write something like this, it was very annoying. We would have to do this. Because if we didn't have those parentheses, it interprets this PEMDAS wise. I hope that helped you with that fraction thing from before. We good? All right, let's